Hello, you're welcome once again. This time around, we want to look at transformation of curves with particular attention to linear curves. Now, we want to remind ourselves of the fact that linear curves are curves which are of the form y is equal to mx plus c, where we know the m, in this case, our m is the slope. Then our C is said to be the y-intercept. Let's take note of that. Our linear curve takes the equation of this form: y is equal to mx plus c. So we're going to look at how best we can transform a given curve, or change, better still, manipulate curves by looking at the y-intercept and the slope given in the question. Now note the key point out of what we are going to do is that now the greater the slope, that is, in cases where m is bigger, you are going to have the curve being more closer to the origin. So assuming you have a curve with the equation y is equal to x plus, let's say, 4. Now this curve that we have here, because it's having 1, is going to be a bit farther away from this origin as compared to another curve which takes the form y to be equal to 2x plus c. Now take note of what is going to happen. What we are just trying to say is that if you look at what we have closely, you realize that the difference between this first equation, say equation 1, and the second equation is what we have here. So assuming I put it before, right? So the difference between these two equations is the slope, which is 2 here. And the impact of the slope is that it makes the curve comes closer to the origin depending on how large it is. So let's look at the first instance, the equation 1, y equal to x plus 4. Assuming we are drawing this curve, note that because the intercept is x is actually on the positive side, we are going to have a point at this end, which is 4. Note, so we are going to have a point 0, 4, which is the x-intercept. The same way, we are also going to have an x-intercept at this point, which is negative 4, 0. So drawing or joining these points, you realize that, let's try to join them. We join and we have our curve. So this curve, which is y is equal to x plus 4, is what we have here. Now attention should be placed on the coefficient of the x, which is the slope, giving us 1 here. In this case it's 1. Let's now turn our attention to the second equation and try to draw it. Now if you draw the second equation, you realize that we also have a y-intercept of 0, 4 as indicated. at this point. But when you come to the x, because we have 2 here, the x intercept is going to move from this end to this end. Let me change colors to make it more appealing and visible. So because the slope here is 2, we are going to move from our original intercept of -4 to -2. So the points here become -2 and 4. Good. Now you realize that when we join these two, let's join them. So our line, so our second curve, which is y is equal to 2x plus 4, has a curve of this nature. And this curve is a bit more closer to the origin than the first curve. So what we are trying to say is that anytime you have a linear curve, the higher the gradient, the more closer the curve to the origin. The smaller the gradient, the farther the curve to the origin. Now in the case of the y-intercept, assuming you have y-intercept, in this case we have 4, it's always proportional, or it always reads from the y positive and then the y negative axis. That is to say, having y to be equal to x plus 4, note that we located our y-intercept at this end where x was given to be 0. The same way, in the second curve, we were given our y-intercept to be equal to 4, because when x is 0, y will definitely be equal to 4. Let's just try to flip these equations and see what happens. So flipping the first equation, we are going to have, so flipping the first equation, we are going to have y to be equal to x minus 4. Now look at what is going to happen here. Since we have our equation to be y equals to x minus 4, our y-intercept is going to be -4 below here. So our points will be written as 0, -4. Similarly, looking at where our x is, our x-intercept is now also going to be located at this point. Yes, it's going to be located at this point, which means because it's 1, it's a bit farther from the origin. But we will be able to determine the relativity when we do that of the second curve, as we flip the second curve. So in joining our curve, these two, good. So this is our first curve, that is y is equal to x minus 4. On the other hand, taking the second curve, which is giving us y is equal to, this time around we are flipping it because we want to change the y-intercept. So we will have y to be equal to 2x minus 4. Now this time around, similarly, our y-intercept is going to be at this point, which is -4. So our point is also going to be 0, -4. In the case of our x-intercept, it's going to drop to this point where we are going to have 2 and what? 0. So joining it, you have this curve. So we have been able to transform this original curve, which is y is equals x minus 4, to be in this form, y is equals to 2x minus 4. And note that because of the introduction of this 2, which is a number bigger than the original one being the slope, the curve has become more closer to the origin than at first. So in transforming curves, what we need to note is that the greater the slope, the steeper the curve. So the greater the slope, the steeper the curve. Now note that, so assuming we have a curve of this nature and the slope is 2, note that if that's the case, then a curve like this will have a slope probably being 4 or 3, because this curve is more steeper than this one. On the other hand, in the y-intercept aspect, cases where you have the intercept being -4, the curve will fall at the -4 aspect. Being positive, it will fall at the positive aspect. So in brief, this is just an introduction. So what we are just trying to draw out is that in transforming a curve, look out for the new equation that has been given, whether or not the equation has a bigger or a smaller slope. Then you also look out for the y-intercept and work it out. So the greater the slope, the steeper the curve is going to be, and the more closer it is going to be to the origin. And the reverse is true. That is to say, the smaller the slope, the more gentle and the more farther away is going to be from the origin. In the case of the y-intercept, actually the y-intercept determines where the curve actually falls. So whether or not it's going to fall on the positive positive x-axis is going to be determined by the y-intercept. So note that when we have our intercept at our original equation, this case being 4, the curve fell on the negative x-axis. In the case where our intercept was -4, the curve fell on the positive x-axis. So let's take note of that. That whenever our intercept is positive, the curve is going to fall on the negative x-axis. Cases where our intercept is negative, the curve is going to fall on the positive x-axis. Thank you so much for watching, and it's bye for now.